In this video, I will be teaching you all about alternating current and its relationship to sine waves. We will investigate how they are made and what they are used for. So by now, you should all be familiar with the concept of a sine wave, or at least what it looks like and how to put it into your calculator. But just as a reminder, the mathematical equation for a sine wave is given by A sine omega t plus or minus phi. Here, A represents the amplitude of the wave, that is, the maximum displacement from the equilibrium point. Omega indicates the frequency of the wave, or how many times one wavelength passes a point in 1 second. T is the specific time, and phi is the phase of the wave, or where on the x-axis does it start. But do you know how a sine wave is generated? As you can see, the amplitude of the wave is given by the vertical height of a ray as it travels around a circle. Mathematically, this is equivalent to the vertical projection of the ray. As a side note, this can also be done with other shapes to generate interesting waveforms. So how does this relate to electricity, you may ask? Well, the electricity you get out of the wall is in the form of a sine wave. The voltage, or amount of energy each electron has, varies in accordance to a sine wave. To produce electricity like this, a generator is used. We know that a conductor moving in a magnetic field induces a current in the conductor, so if a loop of wire is rotated within this field, a current is generated. However, something peculiar happens. As you have probably noticed, the direction of the current is reversed every half turn of the coil. This is what defines alternating current. You can also probably see that the speed of the electrons is also changing. When the coil is parallel with the magnetic field, a stronger force is applied to the electrons, making more of them move quicker. When the coil is perpendicular to the field, however, the electrons don't move. Generally, the coil is turned by steam from burning coal, but this is also how windmills and hydro stations produce electricity. The wind or water pushes on a wheel which causes a small coil to rotate within a standing magnetic field. Well, why use AC, you may ask? It seems to be much more complicated than DC. Well, for starters, it's slightly harder to make a DC motor as more components have to be introduced. And secondly, AC electricity can be transformed, which is essential to transporting power safely and efficiently to your home. Here you can see a transformer at work. The current is transferred to the second coil from the first one. This process can either increase or decrease the voltage, making it safer to use in the home or more efficient for transporting long distances. Thanks for watching. I hope you learned a lot.